Section 5 should be pretty much a pre-calc review. We're going to talk about polar functions here, and we're just going to remind ourselves about what polar functions are and how the variables in a polar function work. And then in Section 6, we'll look at how calculus applies to polar functions. So there aren't a whole lot of notes in this. There's a little bit here. In terms of graphing polar functions, our two variables are r, which is thought of as a radius or a distance from the origin, and theta, which is an angle that we make with the positive x-axis. So if our equation is just r equals a number, that's going to give us a circle. So r equals 5 gives us a circle with a radius of 5. If our equation is theta equals a number, that's going to give us a line at that particular angle with the x-axis. If they have both of those variables, then equations can start to look really cool. So we're going to look at some examples of those. And then the last topic is going to be how we can change polar functions into regular x and y's, or how we can change x and y's into polars. And there's some conversion formulas we can use on those. So first, just in terms of thinking about what our equations are, if I have the equation r equals 1, that's going to be a circle with a radius of 1. R equals negative 1 is also a circle with a radius of 1. A negative distance radius is the same thing as a positive distance radius. It's still just a distance from the origin. So both of those would be a circle centered at the origin with a radius of 1. If I have theta equals pi 6, that's going to be a line at a pi 6 or 30-degree angle with the x-axis. Another equation that would describe this same exact line would be to think about, instead of just going to pi 6, going all the way around to this value, which would be 7 pi 6. Will give you exactly the same line. Yep. Or thinking about going backwards around our circle, negative 5 pi 6 would give exactly the same line. Or negative 11 pi 6 would give exactly the same line. And we could keep on going around and more times forward or backwards, but those are just kind of our first set of answers. Okay. We can graph inequalities as well. So if I wanted to find all the points that meet the criteria, that r is between 1 and 2, and theta is between 0 and pi halves, theta being between 0 and pi halves is going to limit me down to just looking in the first quadrant. R being between 1 and 2 is going to limit me down to the set of points that are a distance of 1 to 2 away. So I get kind of a quarter of a donut.
Donut.
Donuts. Now we're all hungry. I mean, it's just a bagel. That wouldn't, like, even though it's food, it wouldn't be as tempting as a donut.
So you gotta bring your lunch to class.
On this one, if I have just one specific theta value, I'm now limited down to being just a part of that pi 4th line, or 45-degree line. And if I want to work with a radius of between negative 3, I would go backwards a distance of 3 units along that, and forward a distance of 2 units along that, so we get a line segment. If I have r is less than or equal to 0, and theta is pi 4ths, theta is pi 4ths, still limits me down to that 45-degree angled line. And if r is less than or equal to 0, it gives me that endpoint and anything going in this direction. So we get, to use a geometry term, a ray.
Is that a pie on
Yeah, that's a pi on top.
Oh, I see pie now. Okay. Oh, so
I can't comment. I have just as bad as on if not worse.
I'm writing with my finger, so give me a little bit of a break here. If we're only going to restrict our theta and not restrict our r, then theta of 2 pi thirds, I would cut the top of the circle into 3 pieces, and I'd be about there. And 5 pi 6 going to be about here. But they're both full lines. And if I want to be between them, I would end up with that. And since there's no parameter on r, it would be an infinite space growing out in that bow tie.
We do this in geometry or pre-calc?
Pre-calc. Yeah, polar curves aren't seen until pre-calc.
We did 6th grade math.
good one.
Sometimes we did probably. I wasn't even there.
When we start putting r's and thetas together in an equation, I'm not going to expect you to be able to graph these things by hand. So that would be graphing them in the polar graphing mode on your calculator. And this one ends up looking like this, except more symmetrical. It is called a cardioid because it kind of looks like a heart. And we get ones that have little loops in them. And there's a French name for those that I can't pronounce because it has that little C with the tail thing. And I don't know how to do that because I don't speak French. I say limison, but that's not right. I don't know how to actually say it correctly. But it's not really that important that you know what these things are called, but just that you can kind of go into your calculator and be able to graph them. The most important skill that translates from pre-calc to this is not in the graphing, but being able to translate a polar equation into x and y, or being able to translate an xy equation into a polar equation. To do that, there are some formulas that I don't memorize because you guys know I am not a memorizer. So what I'm going to do is think of an angle theta with the r value going out from the center there on my hypotenuse. Then the x side of this would be r cosine of theta, and the y side of this would be r sine of theta. So that gives us a relationship between x and theta and y and theta. And one more equation that's going to be important to us is that since this is a right triangle, x squared plus y squared should be equal to r squared. Because this is a right triangle, we can use our Pythagorean theorem there. Those three equations will allow you to translate, and also that the tangent of theta is equal to y over x. So those four equations will allow us to translate between x's and y's and r's and thetas. So I don't memorize those. Whenever I'm doing a polar problem, I just draw that triangle and figure them out from there because I'm not a memorizer. But if you wanted to memorize those would be the things you would need to know to be able to turn x's and y's into r's and thetas. This is an equation of a circle. X squared plus y squared equals r squared is the equation of a circle. This one has a shift on the y, so that means this thing has moved upwards 3 units, and it has a radius. It's actually up. When it's in the parentheses, it's going in the opposite direction. Yeah, it's usually just in for the x value if the equation is solved for y, but since this one's not solved for y, then they both kind of do the opposite of what they say. So this one would be a center of 3 and a radius of 3. to turn this thing into r's and thetas, what we're going to do is start by doing the algebra on it and squaring out that parentheses. Then I can just get rid of those 9, subtract 9 from both sides, and they nicely cancel each other. Then I want to look for things that are in these purple equations that I can substitute or replace out into this blue equation. And I've got this x squared plus y squared is r squared.
Yeah.
And I've got that y is equal to r sine of theta. So this would be the polar form of that same equation. So you could, in polar mode, graph this. You would have to solve it for r to be able to put it in your calculator. Or with x's and y's, you'd have to solve for y to be able to put that one into your calculator. But both of them give the same circle.
How would you solve it? I don't know.
How would you solve for r?
have
You
to
can't
use
really.
the,
You just have to say, you could factor out an r.
Would you have to use
So
use the quadratic formula?
you could use a quadratic formula. And you could either say that this is the graph of a radius of 0, which is just a point at the origin and not very interesting, or that it is r is equal to 6 sine of theta, and that'll give you the equation of the circle. We'll do one going the other, or two going the other way. If I have r squared is equal to 4r cosine of theta, I want to get rid of all the r's and thetas and turn them into x's and y's instead. So r squared is x squared plus y squared. And r cosine of theta is x. Now you probably can't tell what that's going to be. Okay, I can't look at that and tell what that's going to be. So if I wanted to know what this graph was going to look like, we would need to do some algebra on it. And it's algebra that you have likely forgotten. I'm going to get everything on one side, but I left a blank there on purpose. What we're going to do here is called completing the square.
Oh, I remember that. That was great.
When we complete the square, what we're trying to do is figure out how can I factor this thing as x plus or minus something squared. So I have to figure out what number goes here that allows me to do that. And the rule is that it's half of b squared. So half of 4 is 2. 2 squared is 4.
So it's 4.
And so then this will factor as x minus 2 squared. Since I just added 4 to that side of the equation, I have to add 4 to the other side of the equation is 2. Students always forget that. But it's an equation. We've got to keep it balanced.
Yeah.
So then plus the y squared equals 4.
Wait, why? Are we gonna see this again? Because
Now we square everything.
I don't know what just happened.
To find
4 over 2.
To find this number, the rule is b over 2 squared. So in this problem, b was 4, so we did 4 over 2 squared. We're finding the value that makes it factorable. So by putting a 4 in there, I'm now able to factor that down to x minus 2 squared.
What does D stand for?
B stands for the coefficient of the x term. Just like in the quadratic formula, negative b plus or minus. So that b is the coefficient of the x term. So now when we look at that purple equation, we can recognize that as both things being squared and added together. That's a circle that got bumped 2 spots along our x-axis with a radius of 2.
Yeah.
No, 4 over 2.
I added 4 to both sides, but when that factors down, it becomes the 2.
I'm confused. No.
So just
Why is it x minus 2 instead of x minus 4? Because I thought it was.
I
2
added
squared.
4 to both sides. This b over 2 squared gives you what you add to both sides.
Okay.
But then I have to take that this thing and factor it.
Okay.
And that factors as x minus 2 times x minus 2. or x minus 2 squared.
So you're just looking at what would make it factorable into
Yes.
something in parentheses squared.
Exactly. One more example of turning r's and thetas into x's and y's. Right now, there's nothing that I can substitute from those 4 equations. I'm going to multiply that denominator over and distribute the r through it. So it's 2 r cosine of theta minus r sine of theta equals 4 if I multiply that denominator over and distribute the r through it. And now we have some things that can be substituted. R cosine of theta is x. R sine of theta is y. And this guy turns into a linear equation. And that's the end of section 5.